In this video, we will discuss about some problems on parallel axis theorem. What is the moment of inertia of a rod of mass m and length L about an axis perpendicular to it through one end? You see, this is a rod of mass m, length of this rod is L, and we have to find out the moment of inertia of this rod about an axis parallel to it. Perpendicular to it, about the axis x1 prime. We know moment of inertia of the rod about an axis passing through its center and perpendicular to the rod is given by I equal to m L square by 12. If you allow a axis to pass through the x prime through the center of the rod C, let us say C, then the moment of inertia about x prime will be equal to I, that is equal to m L square divided by 12. And using parallel axis theorem, the moment of inertia of the rod about an axis perpendicular to it through one end is given by I prime. Suppose I prime equal to I plus m into alpha square. We know alpha is the distance between these two parallel axes, that is x1 prime and x prime. This distance is we have taken alpha, and here this distance is equal to L by 2. So if we substitute I equal to ml square divided by 12 and alpha is equal to L by 2, and if you calculate it, then that will be equal to ml square divided by 3. So the moment of inertia of a rod of mass m and length L about an axis perpendicular to it through one end is given by I dash, that is equal to ml square divided by 3. Now let us discuss another problem on parallel axis theorem. What is the moment of inertia of a ring about a tangent to the circle of the ring? Suppose this is a ring of radius r and mass of this ring is equal to m, and this is one diameter of the ring, and this is the tangent of the ring. And using perpendicular axis theorem, we have calculated that the moment of inertia of this ring about one diameter is equal to half mr square. How it will be half mr square? That is the moment of inertia of this ring about one diameter is equal to half mr square. You watch the previous video. And using parallel axis theorem, the moment of inertia of the ring about one tangent will be equal to, suppose moment of inertia about one tangent I tangent, that is equal to I moment of inertia about one diameter, I have written it I diameter dia plus m into r square, because the distance between the two parallel axes here, the distance between the two parallel axes is equal to r, that is alpha is equal to r here we have taken. So the moment of inertia about the tangent will be equal to half mr square plus mr square, that will be equal to 3 by 2 mr square. For more videos in physics, please subscribe my channel. Thank you.